for ethanol, you see, it's a CH3, CH2. The only difference is we're going to erase this part here, like that. And so we have our CH3, CH2, and then what's attached, an OH. Now, oxygen here has how many groups? 2 lone pairs and 2 bonding pairs, which gives us 4. 2 single bonds, 2 lone pairs, 4, which means, what's its EPG? Tetrahedral. So these carbons tetrahedral, this carbon's tetrahedral, this oxygen's tetrahedral. So I'm just going to draw like this and put the hydrogen there. And that means I need one wedged out and one wedged in. And what are those? Those are going to be lone pairs. And so a lone pair that's wedged out is going to be solid, and a lone pair that's wedged in is going to be dashed. And so this is just like what we saw earlier, one coming out, one going in, like that.
Would it be wrong if you put the one that's going in on the bottom of the?
Yeah, if you put it down here, yeah, it would be wrong. It would be wrong. I mean, because if you think, okay, put one leg forward here, one leg back, then would you have one arm down, going down, and then one arm going up like this? No, no. And so you wouldn't have that, right? And so that's why we wouldn't put it at the bottom. It's going to be up. And so this is like this. This lone pair is coming out like this, so you're standing like this. You know, this lone pair is coming out, this lone pair is going in. That's how I visualize that. Now, you know, well, in chemistry, we're most interested in the Mg, And so what we do is we label this. Like, for example, this would be carbon 1, this would be carbon 2. And so carbon 1, what is its Mg? The Mg is tetrahedral. What is the angle? They're all single bonds, so the angle is going to be 109.5. And so the HCH angle should be 109.5, and the HCC angle should be 109.5. Now they're slightly different sized atoms, and so it's going to distort it a little bit. But those distortions with different sized atoms we aren't going to get into. If we go to carbon number 2 here, actually I numbered these wrong. Shoot. In organic chemistry, we number it according to the one closest to the functional group gets 1, and the one furthest away gets 2. So sorry, this should be carbon 2. Now I'm at carbon 1. Here it's the same thing. It's all single bonds. All single bonds then, in this case, all the atoms, so the Mg is going to be tetrahedral. And the angle should be 109.5. They're all single bonds, so we don't expect distortions or huge distortions based on lone pairs or double bonds or that type of stuff. However, oxygen is different. What's the molecular geometry? I know what the EPG is the same for all of these. The EPG is tetrahedral. What is the molecular geometry for oxygen? It's bent. And so the molecular geometry is bent, and the ideal angle should be what? 109.5 degrees. But now we have 2 lone pairs, and that's going to distort it. And so what would you guess the distorted angles roughly? Yeah, 105.5 or just 105. It's actually 109.4 something, so we can round it down to 109. The distorted is going to be about 105. Why is it distorted? It's because of the lone pairs. Lone pairs take up more space. And we have 2 of them, so you have lone pair here, lone pair, it takes up more space. It's going to push these in, and it's going to cause that angle to go down. So that's what we expect. So we could write the angles in here. This would be about 105. All the other angles are going to be about 109. We don't have to be so precise because these are just guesstimates anyway.
So the arrow that you just drew, that's 105, or is it from the H to the O?
No, it's going to be the COH.
Oh, okay.
Yeah, COH angle is going to be about 105. All the other angles are going to be about 109. We don't have much time, so I'm just going to draw acetic acid here. Here you can see. Do you see it? The structure of the acetic acid here. And so the way I draw it is like this. Well, this is tetrahedral here. So I'm going to just draw my standard tetrahedral with 4 single bonds like that. Tetrahedral with 4 single bonds. And then I'll put a hydrogen here, hydrogen here, hydrogen here, and a carbon here. Okay, now this carbon is different. This carbon has how many groups around it? 3. And so 3 means it's going to be what orientation? Trigonal planar. And so what I'm going to do is I'm going to draw. I can draw either. I'll just draw it like this. We'll draw the double bonded oxygen coming up like this, and then we're going to draw it down to the single bonded oxygen like this. So this is a trigonal planar arrangement here. Double bonded oxygen. We'll have a lone pair. And then I go to this oxygen. What is this oxygen? Tetrahedral. Now when I draw tetrahedral, I'm going to draw 2 in the plane, 1 coming out, 1 sticking in. So I want to put the bonds in the plane. And so I'm going to put the hydrogen in the plane. So I'm going to draw it like this. This should be a 109 angle here. So I'll try to draw it at 109 angle here. And so these are the 2 legs here, and then I'm going to have 1 arm sticking out. That's going to be a lone pair like this maybe. And then 1 arm sticking in. It'll be a dotted lone pair. So how should I do it? And so I have 2 in the plane, 1 sticking out, 1 sticking in.
So the lone pair is like symbolizes like a line up.
Yeah, that would be like, this would be a wedge here. This would be a dash sticking in. And so if I were to symbolize those as a line, it'd look like this. One lone pair would be wedged out. This. 1 lone pair would be dashed in. That's how I'm trying to see. So when we look at the molecular geometries, what's the molecular geometry of this carbon? Tetrahedral. This carbon, trigonal planar. Okay, so the HCH angle here should be what? 109. The HCC angle should be 109. The CCO angle should be, yeah, and the CCO angle down here should be 120, and the OCO angle should be 120. So all these should be 120. However, double bonds take up more space. So what that's going to do is it's going to widen this angle to about 122. This one's going to get widened to about 122, which means this one's going to get compressed to about 116. Those are distortions. Now, this is the COH angle should be 109, right? This angle should be 109 because it's tetrahedral. But we have 2 lone pairs. Those 2 lone pairs are going to compress this to about 105. And then we're out of time, so stop.